In the second part of 3.3 today, we're looking at a new type of proof, which is a paragraph proof. We've been doing the two-column proof with statements and reasons. In a paragraph proof, the whole thing is that you literally are writing paragraphs. You're just writing your statements and reasons in sentences. It means you still have to give a reason for every statement that you have. It's just not organized the same. You're just writing it out. So let's practice a paragraph proof here. And this one's fun. This is going to be complex here. We're given in this picture that A is parallel to B. And you see that they're marked with the arrows. A is parallel to B. I'm given that angles 1 and 3 are congruent. Those are marked. And ultimately, I'm trying to prove that lines C and D are parallel. Okay. You know what? I'm just going to start out by writing a little something. We know we always start with given. And I'm doing a paragraph proof, so I'm just writing. I'm going to start by saying I am given that. Or we are given that, it wouldn't really matter. A is parallel to B. Okay, this would be equivalent to us saying statement A is parallel to B, given. I'm given that A is parallel to B. And I wonder what that tells me. If A and B are parallel, can you identify a pair of congruent angles for me? These are the parallel lines that I'm looking at. Maybe I'll highlight those. What angles would have to be congruent? If you notice, with transversal C, the only angle off of transversal C is 3, so that's not really helping us right now. But if I look at transversal D, is there an angle pair off of transversal D with these two parallels that I could say are congruent? Well, actually, take a look at 1 and 2. If I know A and B are parallel, which I do, angle 1 and 2 are what kind of angles here? You should be thinking these are alternate exterior angles. And if A and B are parallel, what do you know about alternate exterior angles if you have parallel lines? You know that those angles are congruent. So I am given that A is parallel to B. This allows me to say that angles 1 and 2 are congruent because they are alternate exterior angles. So I'm going to say, therefore, angle 1 is congruent to angle 2. That would be my statement. And how do I know that? Because of they are alternate exterior angles. Oh, be careful here. This is not a converse. We had parallel lines. We're saying the angles are congruent because of it. Okay. Angle 1 is congruent to angle 2 is my statement. Reason? They are alternate exterior angles. Oh, I should say because of alternate exterior angles, theorem. This was our basic theorem, not our converse. Okay. Let me get rid of these highlights here. Well, what else? Oh, you know what? I have another given. I knew 1 and 2 now because of alternate exterior angles theorem. And I'm going to put just a dotted line. I know 2 and 1 are congruent now. I just want to mark that because it wasn't given. And I got to list my other given. I was also given that angle 1 is congruent to angle 3. This would be my statement. My reason is given here. Well, remember, let's see what I'm ultimately trying to prove. I'm not quite sure where to go from there. I wrote my first given and found something because of it. I wrote my second given. There's got to be somewhere else I can go. What am I ultimately trying to prove? I'm trying to prove C is parallel to D. Okay, I want these two lines to be parallel. To prove lines are parallel, I need a special angle pair to be congruent. And my question is, do I know that there's a special angle pair that's congruent now that will help me show C and D are parallel? Well, what transversal is going to help me? This transversal only has angle 1 off of it. But if I use this transversal, hey, if I could show that 2 and 3 are congruent, if I could show that they are, which I believe they are, right? I marked them now. I'm just going to have to state them here somehow. But if 2 and 3 are congruent, these are what types of angles? These are alternate interior angles. And if alternate interior angles are congruent, ta-da, the lines are parallel by alternate interior angles converse. Remember, the converse says the lines are parallel? So now I just need to show that 2 and 3 are congruent. And are they? Well, right here I had angle 1 was congruent to angle 2. I have angle 1, again, is congruent to angle 3. Aren't 2 and 3 congruent by transitive property of congruence? So I'll say now angle 2 is congruent to angle 3. That's my statement, and it would be by transitive. If I could spell, that would help. My apologies. Transitive property of congruency. There's my reason. So, if 2 and 3 are congruent, oh, wrong line. Sorry. Okay, so C is parallel to D. Because remember, if we can show that alternate interior angles are congruent, the lines have to be parallel. So C does have to be parallel to D by alternate interior angles converse. This is a converse because I'm proving that lines are parallel based on some congruent angles. So a great paragraph proof here. I'll get rid of all these highlights. We're good to go. Notice we started with 2 lines being parallel. I listed a pair of congruent alternate exterior angles because of those parallel lines. Then I used transitive property with those given angles to show, hey look, I have a special angle pair. 2 and 3 are congruent, those are alternate interior angles, therefore lines are parallel by the converse. So great paragraph proof to start out here. One more property for today, and it's the transitive property of parallel lines. We just use transitive property for congruency. We also have transitive property for parallel lines. It says if 2 lines are parallel to the same line, they are parallel to each other. So in this picture, if I knew that P was parallel to Q, P and Q are parallel, I'll mark those each with 1 arrow. And I know that Q is parallel to R. So Q and R I'll mark with 2 arrows here. Then I know that P is parallel to R. It makes sense. If these 2 are parallel, these 2 are parallel, these have to be parallel to each other then. And we're going to use that property here. Imagine each rung of a ladder is parallel to the rung directly below it, which makes sense. You know that all the rungs on a ladder are going to be parallel. I guess in this statement we're saying each rung is parallel just to the one directly below it. And I want to explain why the top rung has to be parallel to the bottom rung then. Well, if I draw a horrible ladder here, I'm just going to use this transitive property of parallel lines like over and over. If I call this, A, B, C, D, E, and I continue down the ladder, I know each rung is parallel to the rung below it. That's what they said. So you know A is parallel to B because B is right below it. And you also know that B is parallel to C, right? A is parallel to B. B is parallel to one directly below it. So now I know that A is parallel to C, right? I can skip from A to C because A was parallel to B and C was parallel to B. So they're parallel to each other. And now I say, okay, I'm going to take that where I know that A is parallel to C, and what do I know C is parallel to? The one directly below it. And C is parallel to D. So use transitive again. These were both parallel to C, A, and D. So now A is parallel to D. Look at that. You have the first and fourth rung parallel. And then you take this. You now know that A is parallel to D. And what is D parallel to for sure? E, the one directly below it. So now A is parallel to E because they were both parallel to D. And I'm just going to say etc. because you could continue all the way down the ladder because you always know it's parallel to one directly below it. Every single one of these is using transitive property of parallel lines. The property we just talked about, using transitive property of parallel lines. And here we did this using, again, transitive property of parallel lines. Again, we use transitive property of parallel lines over and over. A situation when you can use that. So looking at writing paragraph proofs today, I didn't really do a formal proof here, but sort of a paragraph idea and writing this out, an explanation using transitive property of parallel lines. Getting comfortable with our angle pairs and talking about corresponding angles, alternate interior, alternate exterior angles, and the converse.